last year, so I may have to go back and add some stuff later. But 5.4, multiple angle identities. So this is where we'll be using the double angle formulas and the half angle formulas for this. So we have the first one, say to write the expression as one involving only sine of theta and cosine of theta. So 12 sine of 2 theta plus cosine of 2 theta. And they want us to rewrite it using just sines and cosines. So, looking at this, sine of 2 theta, or, well, I don't know what it is in your notes. Mine is sine of 2a. But that only has one option, and so I'm going to rewrite this as 2 sine a cosine a. And then plus the cosine of 2 theta has a couple different ways that it can be written. And ultimately, it really doesn't matter as long as you pick one. They both deal with sines and cosines. So let's just do 2 cosine squared alpha, or why did I say alpha? I just changed all of them to a's instead of thetas. Is that throwing anybody off? I'll go fix them.
Nope, I like it.
And then minus 1. And pretty much that's as far as we can go with that. The only other thing that we could really possibly do is to, actually, I don't even think we can do that. I was going to say to break up the 2 and as 1 plus 1, but it's being multiplied, so that's not going to work. So yeah, pretty much we would just leave it there, but that's written in terms of sines and cosines of just like theta. I do understand that it's being squared, but that's basically as far as we can take those.
And you already said we could take out the 2 because they're just adding.
I mean, I could take out the 2 from these things, but then you'd still have this piece over here, so there's no point in doing that.
And the Pythagorean doesn't work for the 2 cosine squared minus 1 because it's
The 2 is
because of the 2.
distributed.
Yeah.
Yeah, the 2 is not being distributed, but even still, you'd have cosine squared minus 1, which isn't technically the identity. Yes, you could manipulate an identity, but because of this 2 here, it doesn't really work. So
It'd be a little bit more.
I'm not saying there's absolutely no other way we could do this, but this is sufficient for what it says to do in the instructions. They're not going to ask you something like that on the exam. It's like, just write it like this. Like, you'd be able to tell easily what they are.
Okay.
Solve algebraically. Hold on. Let me make sure I'm not missing anything. Yeah, solve algebraically for the exact solutions in the interval 0 to 2 pi. So 24, we have cosine of 2x plus the sine of x is equal to 0. So basically, this is just like what we were doing with verifying, where we don't do anything to the right side. I'm not going to like subtract sine of x over or something like that until I get all the way down to the end where I'm actually solving, like that part. Not to say I couldn't, but if we think about it, when we do like the zero product property where we like set everything equal to 0, that's basically what we're trying to get to. So that's why I don't want to move it over. So I want to rewrite this if I can. Being that this is written as the sine of x here, and this is the thing that would be rewritten because it's a double angle, I would probably want to go to my sheet and say, okay, well, which one deals with just sines? Because it's probably going to make my life easier.
1 minus 2 sine squared theta.
Yep, 1 minus 2 sine squared of, in our case, x plus sine of x is equal to 0. I would probably take and reorder this and write this as minus 2 sine squared of x plus sine of x plus 1 is equal to 0. And then if you can recognize it without doing it, you can go ahead and factor this. If not, I would say use u substitution. So let u equal the sine of x. So then I'd have negative 2u squared plus u plus 1 equals 0. And then I would factor that. So what would that factor into?
2, -2.
Have to use the arch method. This isn't anything
Plus
special.
2u minus u.
Yep. Then factor by grouping, and I would leave this as terms of u all the way down until I have finalized it and it's two parentheses, and then I would plug the sine of x back in. So this would be, I'm going to take out a negative 2u. So then I'm left with u plus 1, or sorry, minus 1. And then I'm going to take out a negative 1 over here, so I have u minus 1. So I've got negative 2u minus 1 times u minus 1 equals 0. Now at this point I would plug my sine of x's back in. And so I would have negative 2 sine of x minus 1 times sine of x minus 1 equals 0. And then we're going to set both pieces equal to 0 and solve. So I've got negative 2 sine of x minus 1 equals 0 and sine of x minus 1 equals 0. So then I've got sine of x is equal to negative 1/2. So these are a little different than when we're taking the inverses. While that is technically still kind of what's happening, I'm ignoring the rules of finding that with the inverse because I'm trying to find everywhere on the interval from 0 to 2 pi, because that's what it says in the instructions, that sine of x is equal to negative 1/2. So where does that happen?
No, huh? Where did what happen?
On the unit.
Where is sine of x negative 1/2 on the unit circle?
The bottom left quadrant.
Okay, what does that equal to?
Sine is y, so negative 1.
Do you want radians? Degrees?
Radians.
4
7
pi over 7.
6.
Dang.
7 pi over 6, and what else?
And then
11 pi.
11 pi over 6. Y'all gotta know that unit circle like the back of your hand. Over here, we move this over. Sine of x is equal to 1. Where's sine of x equal to 1?
when sine is equal to 1, it is that 1 given? Pi over 2.
Pi over 2.
How the heck is it pi over 2? Oh, whoa. 0,
Yeah.
1.
Y'all are gonna struggle on that AP exam if you don't know your unit circle. All right, use the half angle identities to find the exact value without a calculator. So I'm just going to tell you this is probably one of the topics that we'll probably come back to when we're doing our AP review to actually hit more AP style questions. Because our book isn't written that way, it does a lot of questions that are like very weird in here and things that you don't need. So that's why we're kind of like skipping a lot. So this is one of those things we'll probably come back to. So you'll have only like a few that you're really dealing with this stuff in addition to what you had the other day with the other things. So I'm just letting you know that. So 32, we have the tangent of 195 degrees. So we're using our half angle identities here. And so we need to figure out what this is basically the half angle of. So we're going to say let u over 2 be equal to 195. Then that means that u is equal to what?
195. Oh, wait.
No,
No.
half of 195.
No.
It was
195 times 2.
times.
Dang it.
So 3 something.
390. So u is going to be 390 degrees. Now, is 390 degrees on my unit circle?
No.
No. So sometimes that happens and we need to find a coterminal angle with it. How do I find a coterminal angle?
Subtract 360.
In this case, subtract 360. So that means that we're going to treat this like it is 30 degrees. So, we're going to look at this as the tangent of 30. Now, this isn't like just go to the unit circle and write this value down. Okay? Because it's not technically 30, obviously. But we're going to use the formula, our half angle formulas. You can use either one. Well, actually, there's 3 of them. You can use any of the 3 of them. I would probably choose one of the ones that's not in a square root. Just my recommendation. But let's just use the sine of u over 1 plus cosine of u. So we've got sine of 30 over 1 plus cosine of 30. What's the sine of 30?
Sine 30,
1 half. Over 1 plus cosine of 30.
cosine of 30 is going to be
Root 3 over 2. I would go ahead and get a common denominator here on the bottom. So I'm going to scratch this 1 out and write it as 2 over 2. So I have 1 half over 2 plus root 3 over 2. Then we do Shepherd's favorite thing. We're going to keep change flip and get 1 over 2 plus root 3. Then what would I have to do?
multiply by root 3 to get it off the bottom.
Can't just
Well,
multiply by
conjugate.
root 3. The conjugate, so 2 minus root 3. And I would get 2 minus root 3 over 4 minus 3. Obviously that's just 1, so this ends up being 2 minus root 3.
Is that the tangent of 30 or is it the tangent of 195?
You scroll down.
Technically it's the tangent of 195, but that's why we can't write it this way, but we're using 30 as what's getting plugged in here.
How does the tangent of 30 give us the tangent of 195?
It's not really the tangent of 30. It's the half angle of this. It's really the half angle of 390. But that's not a value on our unit circle, so we had to find the coterminal angle.
Okay.
So it's technically that, but we just found the coterminal. So I just put that in there so you see what we're plugging in, because you can't plug in 390.
Yeah.
I mean,
Okay.
you can, but it's harder.
Are we doing one more? Or like a couple more? 'Cause I didn't want to interrupt, but I have to use the restroom.
2 more. All right, the 34 sine of 5 pi over 12. All right, so this is the half angle. So that means that we're going to let u over 2 be equal to 5 pi over 12. So what does that mean that u is?
10 pi over 24.
Which reduces to
6 pi over, oh yeah, 5 pi over 6.
5 pi over 6. So I'm looking at the sine of 5 pi over 6.
Top left quadrant. Wait, no. Wait.
So is sine positive or negative there?
Positive.
So we've got positive, because these are the formulas where we have to choose positive or negative. And then we have the square root of 1 minus the cosine of 5 pi over 6. All over 2. What's the cosine of 5 pi over 6?
Root 3 over 3.
So So I'm going to go ahead and write the 1 as 3 over 3. And then minus, it's not root 3 over 3.
It's not.
Root 3 over 2.
Oh, yeah, I said the tangent.
So 2 over 2. Yeah, that's what I registered to. When you said that, I was like, oh, yeah. And then I was like, oh, no, it is not. Now, at 5 pi over 6, is it positive or negative?
Say again.
Is cosine positive or negative?
Cosine's
Negative.
negative.
It's negative, so that means that this sign in here needs to change to a positive. Because it'd be minus a negative. And then all over 2. So now, this up here is really one fraction on the top. So this is the square root of 2 plus root 3 over 2. Well, when I'm dividing by something like with fractions, it's the same as multiplying by 1 over that number. So really, this becomes the square root of 2 plus root 3 over 4. So then the top stuff will stay in the radical, so that'll be the square root of 2 plus root 3. And then the bottom, the square root of 4 is 2. And so then this is where we would leave our answer. Now let me look. You may also see the book. I don't know why they do this. I mean, I kind of do, but I also kind of don't. You may also see the book do this as the answer. It's the same thing. I would just leave it here. But I'm just letting you know for the purposes of checking that they sometimes go to here. And then lastly, let's hit a cosine one, 36. Cosine of pi over 8. So let u over 2 be pi over 8. So u is equal to
2 pi over 6, so pi over, yeah, what angle is it?
pi over 4.
Oh, but this one's easy. Wait.
So then cosine of pi over 4 is cosine positive or negative there? Positive. So then I've got the cosine formula is the square root of 1 plus the cosine of pi over 4 all over 2. Yep, cosine of pi over 4 is root 2 over 2. I don't know why I changed colors in the middle of that problem. So this is, again, because I'm going to write this as root 2 over 2, I'm going to write the 1 as 2 over 2 plus root 2 over 2 all over 2.
Is the over 2 part still under the radical?
Yeah, I just didn't make my thing big enough. So then I have the square root of 2 plus root 2 all over 2 times 1/2 to take care of the divided by 2 part. And if you can kind of like skip some of this stuff of like not having to write everything, feel free to do that. So then this is going to be the square root of 2 plus root 2 over 4. And then same thing happens that we had happen before. We end up with the square root of 2 plus root 2 and then all over 2, not in the radical. Or the way the book would write it, 1/2 and then the square root of 2 plus root 2. So again, either way is fine. I would take either one. But part of the reason that we'll probably more so come back to this section as we're doing AP review is because more of how you're going to see this stuff come up, not that you're never going to solve a problem like this for them, but more so what you're going to see is when we do the problems like the verifying and the simplifying is it may involve a double or a half angle and you need to rewrite it in terms of the way that these identities are written. Okay, especially the double angles. They're not so much used for solving, but for rewriting things. So, but this book doesn't do a great job with that, so that's one of those things that we will come back to later on as we're doing review. So, just a few problems that go with this. 11, 23, and then 31, 33, and 35. So that'll give you one of each, sine, cosine, and tangent for the half angles. And then, let's see if there's anything else. One multiple choice question, 50.